Hello again. We are continuing to work on the gateway questions for Math 104. This is question number 27, solve for x in the following equation. So, one technique that is rather handy in these types of problems is notice that 2x squared minus 7 appears multiple times in this equation. Here it's being cubed, and here it's being subtracted. So what we might do to clean things up is we might first substitute u equals 2x squared minus 7. This will just make the equation a little bit easier to solve, a little cleaner. So with this substitution in mind, let's instead solve the equation u cubed minus u equals 0. Well, what can we do now? Well, notice that each of these terms have a power of u. Here it's u cubed and here it's u. So I can go ahead and factor that out and get u. And what's left? If I factor out a u, I'm just going to essentially divide each of these terms by u. So I'll get u squared minus 1 equals 0. Well, what to do now? So let's take a look at this quadratic. Here we have u squared minus 1. And we could use the quadratic formula. That would certainly work. But sometimes that is sort of overkill. You know, it's more work than we need to do sometimes. So notice that this quadratic has the form something squared minus something squared. In fact, if we go off to the side for a second, if we remember our difference of squares, a squared minus b squared, notice that that factors as a plus b times a minus b. This is a very useful identity to keep in mind. So in this problem, notice that u squared is playing the role of a squared, and 1, is playing the role of b squared. So that means that this quadratic will factor as a plus b, or u plus 1, times a minus b, u minus 1. And we had our factor of u from earlier. So we've completely factored this polynomial, which is excellent. That means we can look at the individual factors to solve for u and then solve for x. So let's start with the simplest one. We have u equals 0. Then we have u plus 1 equals 0. And then we have u minus 1 equals 0. So it's straightforward to figure out what u must be in each of these equations. Here we have u equals 0. Here we have u equals negative 1. And here we have u equals 1. But remember, our goal was to solve for x, and all we've done so far is to solve for u. So now what we're going to do is we're going to take our original substitution and rephrase these equations in terms of x. So everywhere I see a u, I'm just going to replace it with 2x squared minus 7. So in particular, I get 2x squared minus 7 equals 0. 2x squared minus 7 equals negative 1, and 2x squared minus 7 equals 1. Notice that these equations all sort of have a similar form, so we can kill 3 birds with 1 stone and sort of solve them all together. Okay, well, this is a quadratic equation, and while we could again use difference of squares, I think it'll just be easier to isolate the x squared term and then take square roots. So to do that, first thing we should do, we're going to isolate the x squared term. So let's add 7 to each of these equations. So what we're going to do is just add 7 to each of these three equations. So I'm going to add 7 to the left and right hand side, and I'll get 2x squared equals 7, 2x squared equals 6, and 2x squared equals 8. Okay? Well, if our goal is to solve for x, we're going to continue to isolate x on one side of the equation. And the next step is to divide each of these by 2. So we'll get x squared is 7 halves, x squared is 6 halves, and x squared is 8 halves. Of course, we could simplify some of these answers numerically, but there's no need to do so, and especially in more complicated problems, it's best not to. So, we've isolated x squared. How do we extract x? Well, by taking square roots. And notice that all of these numbers are positive, so each will produce a valid solution. If, for instance, this was x squared equals negative 6 halves, that does not have a solution in the real numbers, so we would omit it. But we can take square roots cleanly here and get x equals square root of 7 halves. Notice that we should include the positive and negative square roots, and similarly for the other two. And now, these 6 values of x are the solutions for the original equation.